All right, so this is my screencast for dataset 4, right? Dataset 4 looks like we have t. Well, that's usually time, especially if it's measured in s, which probably seconds. All right, and then this looks like v, or velocity, measured in meters per second. All right, and so this would be 0 0.3, 1.2, 2.7, 4.8, 7.5, 10.8, 14.7, 19.2. All right, then we got 10, 20, 30, 40, 50. What did I do wrong? 60. Something's wrong. 80, 70, and 80. So 19.2 should be down here. Whoops. 14.7, 10.8, and this should be 7.5, and this is 4.8. Oh my goodness. And then that's 2.7, 1.2, and 0.3. Okay, now I'm good. So let's just like center everything. Whoops, haha. There. And then I'll make this bold, highlight my data, and let's see what it looks like. Oh great, my silly little column chart. I gotta just change the defaults to scatter. I wonder how you do that. Whoa! Look at this. Are you serious? Oh my goodness. So this looks like this is velocity versus time. I wasn't expecting that. And then let's see if I can just label by clicking on it. That would have been cool. Can't do it. So my vertical axis is velocity, I'm guessing. Yeah, it is. Velocity in meters per second. There are systems that would do this, by the way. Time, seconds. Okay. I don't know what that system would be right off the top of my head, but I'm sure there's something real that would do this, where the velocity would increase in this pattern. Well, side opening parabola, that implies that velocity squared is proportional to time, right? So I'm just going to copy time, right? Equals, bam, return, and then copy this down, right? And then I'm going to square velocity, right? So I'll say velocity squared. Put a parentheses there, and that makes meters per second caret 2, right? So then I say equals, and then I'll select that, and I'll square it. And then I'll just copy that procedure all the way through my data. Wow, look at how the data just explodes right here. So now I'm going to graph velocity squared versus time. See what that looks like. Okay. Whoa. It just puts graphs right on top of one another. Here, I'll put it down here. Let's put this here, and then put this here. Then I'll go here, and I'll put scatter. Wow, that looks very linear, so I think we're good. Let's label this. So this is a graph of, whoops. This is a graph of velocity squared versus time, right? And then my horizontal axis is time, right, in seconds. Whoops. Whoops. Haha. And then my vertical axis title is velocity squared. And that's meters per second squared. Don't forget those units are squared there. All right. So I can put a trend line because that data set looks linear now. I can put my equation as my label, and I can put my equation inside my graph. And then I'll write my equation here. Okay, so I got velocity squared equals, and I got 333 as my slope. Whoops, haha. So let's put parentheses around my slope. And the units of my slope are kind of complicated. I'm going to need, this is going to be complicated, meters per second, but I'm going to need a parentheses around that, right? Because it's meters per second squared over seconds. Oh, that's annoying. So what does that become when I simplify it? Meters squared per second squared over seconds. Oh, that's complicated. All right. Well, oh well. I'm just going to leave it alone. Yeah. Meters per second. Let me think about it. Meters per second over seconds. What does that simplify to? I'm just going to write it on a paper and figure it out. Meters per second squared over second. So that's the same as meters squared per second squared times 1 over second. So that's meters squared over seconds cubed. That's what that is. So I'll write that, meters squared over seconds cubed. I have no idea what those units mean, but okay. And then what's my other variable? At least I got the correct units on my slope. It's just time. And then I have an intercept that's a really small number. I'm going to call it 0 because it's so small. 4.5 times 10 to the negative 13. Okay, it's 0. And then the units on that are meters squared per seconds squared. And looks like I'm done. There we go. I don't know how I'd make sense of my slope and intercept, but at least I do have an equation for this line and for this curve. So that's kind of cool. All right. That would be data set 4. Hope that helps.